Okay, so welcome back. Now we're gonna go over a quick review on the basic concept regarding triangles. I don't know for some reason, but this test, they really like exercises with triangles. So let's start talking about triangles and let's see what is the relationship of angles, okay? So we have a triangle. First thing that we know, let's say that the angles are x, y, and z. So first thing that you need to be clear on is that the sum of the inner angles, so x plus y plus z, will be equal to 180 degrees, okay? Please do remember that. Now, there is something else that we would like to identify here is that in triangles, there is always a direct relationship between the sides and the opposite angles. Meaning, if I have this triangle, and let's say that this is triangle A, B, and C. So what we're saying is that this angle right here, angle A, is directly connected to this side. Okay, so we're gonna call this lowercase a. This angle B is connected to this side here, so we're gonna call this lowercase b. And angle C here, the opposite side will be this one right here, so we're gonna call this one small c. There is always a direct relationship between the angles and the opposite sides, or vice versa, the sides and the opposite angles. Why is that important? For example, if we say that we have a triangle here, and this is angle A, again B and C, and we don't know the measures of the angles, but I know that this side maybe is 5, and let's say that this guy is 5, and this one is, I don't know, this one is 8. So keeping in mind that connection between the sides and the opposite angles, right now I can guarantee, see, this angle A is connected to this 5, angle C is connected to this 5. So even though if I don't know the measure of the angles, but I can guarantee that angle A is equal to angle C. Why? Because they are opposite two sides that have the same length. So that we can guarantee. The same here from this guy, we can also conclude that B is connected, is related to this side, that is 8, which is greater, right? That is the greater side. So that also takes us to be able to guarantee that B is definitely greater than A and C, because A and C are equal. So because B is opposite to the longest side, we can guarantee that that will be the greatest angle, okay? That's always something that we get to conclude. To visualize in some other way, again, we're gonna have A, we're gonna have here B, we're gonna have here C. And if I say that this side is 2 and this one is 7, so this is gonna be maybe 8 again. So let's do it with different colors. So angle A, remember, is connected to this side, right? To 7. Angle B is gonna be connected, related to this side, that is 8. And angle C is gonna be connected or related to this side, that is 2. So if we want to organize this from greatest to least, again, even though I don't know the measure of the angles, but definitely I will be able to guarantee that angle B is the greatest because it's the opposite to the longest side, and this angle B will be greater than angle A, will be the second one in order because it's opposite to side 7, which is the one in the middle in terms of length, and this is greater than angle C because C is opposite to the shorter side. So this relationship always applies, okay? Now, let's talk about isosceles triangle. Isosceles triangle are which ones? Remember that isosceles triangles, everybody tend to say, okay, they have those triangles that have two equal sides. Yes, but remember what we just said. We always need to be clear on having equal sides, and we need to start thinking of angles as well. Always in triangles, sides and angles. So if I have a triangle with two equal sides, that means that the triangle also has two equal angles, right? At the end of the day, we just need to know which one are the ones that are equal. So again, we have the case. This is angle B, this is E, and this might be F, okay? So at any given moment that you know that maybe angle side BE is equal to side BF, right? So here what I'm saying with the drawing is that side BE is equal to side BF. So if we know that these two sides are equal, again, we can guarantee that the opposite angle, so the opposite to this side is this guy, is F, right? The opposite to this side, it will be this one, which will be E. So knowing that, which are the opposite angles, we can also guarantee that angle E is equal to angle F. All right? Another example. We have, well, I meant to be a straight line. You have this triangle, okay? And let's call this triangle, I don't know, X, Y, Z. And in this case, I will tell you that this side is equal to this side. Again, making the projection, we know that this angle, that is the opposite, will be angle Z, and the opposite angle to this side, which will be this one, which will be angle X, they are equal. So just by checking out that figure, not having read anything else on the statement, if we are solving an exercise, but we can also guarantee that angle X is equal to angle C. Okay, because that relationship that exists always between the sides and the opposite angles on a triangle. All right, so this is what I need you to keep in mind about isosceles triangles. Now, equilateral triangles. So what is the definition of an equilateral triangle? All sides are equal, so basically we have three equal sides. And again, don't forget about the angles, which also means that you will have three equal angles. Okay, three equal angles. And remember, because we know that the sum of the angles in a triangle is equal to 180, this automatically means that if we have an equilateral triangle, we already know that each angle measures 60 degrees, right? Automatically. So keep this in mind. When you see equilateral, three equal sides, three equal angles, and automatically we know that each angle will be equal to 60 degrees. Now, the next kind of triangle that we need to discuss is the right triangle. If you remember, the right triangle is that one that includes a right angle. And you remember that the right angle is that one that takes a measure of 90 degrees. So, on a right triangle, let's draw it like this, okay? And remember that normally it's indicated by this little square on a corner. So this right here, I'm indicating that this is a right triangle, okay? In a right triangle, remember, this side is called the hypotenuse of the triangle. And these two sides, the two sides that form the 90-degree angle, is what you call the legs of the triangle, okay? And again, be aware of this terminology because the only triangle that has hypotenuse and legs is the right triangle. So even if at any given moment you are not given the drawing, like the figure, you don't get to see it, but they talk about legs and hypotenuse, automatically you know that you're talking about a right triangle, okay? And along with the right triangle, there is one famous friend that, if you remember, was named Mr. Pythagoras. So what did the Pythagorean theorem say? Or says still, because it's still valid. So let's say that this is side A, let's say that this leg, we call it B, and the hypotenuse is what we will call C, okay? So Mr. Pythagoras stated that when we have a right triangle, said that the length of the hypotenuse square will equal to the sum of the square of the other legs. So this will be equal to A squared plus the other leg squared. So this was or is the Pythagorean theorem, and is very useful. And many times you want to find distances or given points, so we can always kind of create a right triangle and apply this one. Even though for us to be able to apply Mr. Pythagoras theorem, we need to know two of the three sides, right? But this is the Pythagorean theorem. Now, the Pythagorean theorem is nice, but there are, or it has a restriction. As I just said, for us to be able to use Pythagoras, we need to know two of the three sides. These two special right triangles that we call them special because by knowing only one side of the triangle, we automatically can deduce the other two sides. There are two specific cases, the one that we call the 30, 60, 90 triangle, and the other one is the one that is 45, 45, 90. So this 30, 60, 90 y well refers to the measurement of the sides, okay? So if I have a triangle, use your imagination, let's say that this is a right triangle. We call this 90, this guy will be 30, and this other angle will be 60, okay? So this is the relationship. The shorter leg will be kind of our base, that's what we call x. If we know this side, we know that the hypotenuse equals 2x, and the other leg will be equal to x times square root of 3. So check out that all the sides are connected or are related with x. So in any given moment, if we know one side, automatically we can deduce the length of the other two sides. Okay? For example, let's say that I have this triangle. This is 90, this guy is 30, this guy will be 60, again, related to the triangle that we have above. So let's say that in this specific case, I'm going to say that this side equals 10. So what we are doing is, if we compare this triangle to this one that I have here, that is kind of my model, I'm giving you the length of the hypotenuse. And here, we know that the hypotenuse will be equal to 2x. So from this information, we can deduce that in this case, x must be taking the value of 5. Right? Just by comparing these two x will be equal to 10, meaning that x should be 5. If we know the value of x, so we know that the shorter leg will be 5, and the longer leg will be equal to 5 square root of 3, and that's it. We already solved the triangle, okay? This is how these special right triangles come handy. So this is the 30, 60, 90 triangle. The other special triangle is the 45, 45, 90. So it's an isosceles right triangle. Okay, because this is 90, this guy will be 45, this guy will be here 45. And again, remember, 45, 45, 90, that is the same whenever you read, because I have seen it, that they give you an isosceles right triangle. We are also talking about this specific triangle, the 45, 45, 90. And in this case, the relationship among the sides is kind of easier because the legs are equal, right? X and x, on what we just reviewed before. The sides to opposite to these two equal angles, so they should be equal. So x will equal to x, and the hypotenuse in this case is given by x is square root of 2. All right. So again, let's come up with an example. We have the triangle here. You know that it's an isosceles right triangle, so this is 90, this guy will be 45, this guy will be 45, and you know that this guy is, I don't know, 2, so automatically we know that the other leg will be 2, and the hypotenuse will be equal to 2 square root of 2, and voila, we solved the triangle. These are going to be very handy whenever you see 30, 60, 90, or a 45, 45, 90 triangle. Automatically think of these guys. Again, in the SATs, you find this information on the very first page of the section, but the other exams, GRE, GMAT, please do memorize this relationship, and I can guarantee that there will be questions where you just are required to use the definition or these properties of special right triangles to be able to solve the exercise. So do keep them in mind. And the last concept that we're gonna review in terms of triangles is this one. I don't really remember if this has a name or there is a theorem or something. I just call it relationship among sides. There is a property that triangles have, regardless of the triangle. It could be isosceles, equilateral, right triangles. And let me try to explain this thing with an example already. Let's say that this side takes the value of 5, maybe. This side can be taking the value of, I don't know, 3. And this we don't know, this will be x. So the question is, can x take the value of 1, 2, 3, 4, 7, 8, 9? So if we were to draw this triangle, what could be a measure of side x? I can tell you that it's not going to be 1, it's not going to be 2. It can be 3, yes, it can be 4, it can be 5, 6, it can be 7. It cannot be 8 and it cannot be 9. It's going to be always only values between this range. Why? The property here says that, let me write it down, the length of a third side, okay, the length of a third side of a triangle, must, it's not optional, it's obligatory, must be between the, and pay attention here, between the difference, so like the subtraction, okay, the difference, and the sum of the other two sides, okay? So the length of a third side, in this case x, must be between the difference and the sum of the other two sides. So how do I know that this is going to be between 2 and 8? Because again, I know x, so what we're saying here is that for us to be able to know what could be the value of x, we know that this x must be between the difference. So the difference here will be 5 minus 3. So x must be right here in the middle, in between, and the sum of those other two sides. So whenever we solve this thing, we know that the value of x must be a number that goes between 2 and 8. Okay, cannot be 2, it's not inclusive. Check it out, that is not less than or equal to. It is, cannot be 8. Can it be 3, 4, 5, 6? It can be 7.9, it could be 2.01. Yes, as long as it's greater than 2, there is something, it's a triangle that exists, you know? Let's say that a triangle that takes the values 5, 3, and 1, or 5, 3, and 2, that triangle does not exist. It is impossible for us to draw that triangle. And if you want to, give it a try at home. And the thing is that if the value is 2 or less, when you draw it, you don't get to close the triangle, you know, like the sides are going to be two sides that you never touch. And if the value of x is longer, is 8 in this case, or greater, what will happen is when you draw it, like, you know, one side will go over, so they will not really intersect at the vertex. You will have to draw it a little longer. That's what happens, okay? So this is a property that at the end of the day is not useful in life, but in this exam, I have seen several exercises where knowing this concept is relevant, okay? So here, as a final example, let's do this one, guys. As another example. Let's take this guy. Let's say that right here, this is our x, and this side is, I don't know, 3, and this side right here will be 7, okay? So try to think which will be the possible values of x, and see if we get the same. If we do it, what I will say about x is that x must be taking a value that goes between the difference, so 7 minus 3, and the sum, so it will be 7 plus 3. So this will be 4 and 10. So x can take any value that is between 4 and 10. Okay? Again, not important in life, but this is one of those concepts that very few people remember, and I can guarantee that it's going to be evaluated at some point in these exams. All right? I hope that this helps, and well, I'll see you in on the next video.